4 here, you're asked to find the perimeter, area, the equation of the perpendicular bisector, and the equation of the altitude in this problem. So let's just go ahead and draw it in really quick. So you got A is 1 over -2 down. B is 3 over 4 up. C is 9 over 2 up. And D is 7 over -4 down. And so those are our points. And so we've got this quadrilateral where it's A, B, C, D. And so we'll start with perimeter. Well, the perimeter, we're just going to define the length of each of those sides. And so to find the length of a segment on a coordinate grid, we use the distance formula. And so if you remember, the distance formula is equal to the square root of the difference of the x values. So let's just do AB first. And so we'll keep track of what we're doing here. AB is going to equal 1 minus 3, difference of the x's squared, plus -2 minus 4 squared. Remember, the order of those two doesn't matter because of you're squaring things. And so that's going to give us 4 plus 36. So that's going to give me 2 root 10, or root 40, because it's 4 plus 36 is 40, which is the same as 2 root 10. And then if we look at BC, BC is going to be 3 minus 9 squared plus 4 minus 2 squared, which maybe you notice that you get 36 and 4, so the exact same thing. So that one's also 2 root 10. And then CD is the square root of 9 minus 7 squared plus 2 minus a -4 squared. And again, we get another 40 because this one is 6, so 6 squared and 2 squared. So that's also 2 root 10. And then finally, AD is going to be 7 minus 1 squared plus -4 minus a -2 squared, which is also going to give you 36 plus 4, which is 40. And so you get 2 root 10 again. And so it turned out all four sides are the same. And so this is a special kind of quadrilateral. It's a rhombus. It's also a parallelogram. Okay, to find area, well, you can't use that, though, to find area. Your area isn't necessarily going to be because we don't know if this is a square or not. So to find area, you can do a couple different things. But one of the things that you can do to find the area of this is to do the shoelace theorem. And so if you remember the shoelace theorem said you list the points in either clockwise or counterclockwise order. Always relisting the first point again. Then we draw our shoelaces in by multiplication. So -2 times 3 is -6, and then 36, and 14, and -3. And so that gives me 50 minus 9 is 41. And then I add those together, if you remember. And then I do shoelace the other way. That gives me 15 minus 36. So you get 15 minus 36, which would give you negative 21. So let's go through and check our work here. Oh, I did my multiplication here wrong. This should have been -4, correct? And so this side, that side should have actually been 40. And then I did the same thing wrong down here. This should have been 7 times -2 is -14. And so that one's going to be -40. And so now when I look at this, I take the difference of the two sums, 40 minus a -40, take the absolute value of that, and then multiply by 1/2. And so my area turns out to be 40. If you were to multiply 2 root 10 by 2 root 10, it does equal 40. And so this did actually turn out to be a square. All right, now we need to find the equation of the perpendicular bisector of AB. And so remember, a perpendicular bisector goes through the midpoint. And so when we're looking at this one, I'll go ahead and erase all this so we get some room here. So we look at the midpoint of AB, and then it is perpendicular to that line. So we'll need the slope of AB. And so our midpoint of AB is going to be, remember the equation of midpoint is add the x coordinates together divided by 2, add the y coordinates together divided by 2. So that gives me 2, 1. I need the slope of AB, and so that's going to be subtract the y's, -2 minus 4, over subtract the x's, 1 minus 3. So -6 over -2, which is 3. And it's a perpendicular bisector, so it goes through that bisecting point, which is 2, 1, but it's perpendicular, so we have to do the negative reciprocal of that slope to get -1/3. So it's going to be y equals -1/3 x plus b. Substitute these points in, you get 1 equals -1/3 times 2 plus b. Add 2/3 to both sides, you get 5/3. So b is 5/3. So the area of our bisector is going to be y equals -1/3 x plus, and we found our y-intercept to be 5/3. And then it said you need to find the altitude of the quadrilateral from AD to B. And so this is AD to B, and so we need to go from this point, a right angle, down to here. And so we already know the point that our line's going to go through, that's B, and so that we know our point's going to be 3, 4. But it needs to be an altitude, and an altitude always hits the line, that is, the opposite line, at a right angle. And so we just need to find the slope of AD, and then take the negative reciprocal. So the slope of AD is going to be -2 minus a -4 over 1 minus 7, and so that turns out to be 2 over -6, or -1/3. The negative reciprocal of that is 3. And so the slope of our altitude is going to be 3. So you do y equals 3x plus b, substitute in the point that you're going to go through, which is b, and so that's going to give you 4 equals 3 times 3 plus b, so b is -5. So our equation is y equals 3x minus 5, or plus a -5.